The sky is filled with stars during the night, and some of us wonder if this particular star is closer to our planet because it is bigger than most others. But the truth is, one of the nearest stars to the Earth is a triple star system called Alpha Centauri. However, as we all know, the universe contains much more than what meets the eye. Therefore, this also applies to Alpha Centauri. So, are you excited to know more about our nearest star? Well then, switch this video to full screen and watch this video till the end. Hello everyone. Welcome back to the Tech Universe. Before starting, don't forget to hit the like button and subscribe to our channel to get more updates on the space and tech world. That being said, let's begin with the basics. So, basically, there are two main stars in Alpha Centauri, Alpha Centauri A and Alpha Centauri B, which form a binary pair. Based on NASA's calculations, they are located about 4.35 light-years away from the Earth. The third star is called Proxima Centauri or Alpha Centauri C, and it is about 4.25 light-years away from Earth, making it the nearest star, other than the Sun, to us. NASA's data indicates that Alpha Centauri A and B are on average about 23 astronomical units AU away from each other, a little more than the distance between the Sun and Uranus. An astronomical unit refers to the average distance between Earth and the Sun, which is equal to 149,597,870 kilometers. According to NASA, the closest the stars have ever come to each other is 11 astronomical units, and they orbit a common center of gravity every 80 years. Proxima Centauri, on the other hand, is about 1/5 of a light-year or 13,000 AUs from the two other stars, a distance that makes some astronomers question whether it should even be considered a part of the same system. However, Proxima Centauri is about 1/5 of a light-year away or 13,000 AUs from the two other stars, a distance that makes some astronomers wonder whether it should even be considered. Proxima Centauri is about 1/5 of a light-year from the two other stars, a distance that makes some astronomers question whether it belongs to the same system at all. Alternatively, Proxima Centauri may be passing through the system and leaving in several million years, or it may be gravitationally bound to the binary pair. If it's bound, it has an orbital period of about 500,000 years around the other stars. Alpha Centauri A and B are visible to the naked eye as one, making them the third brightest star in our night sky. With a small telescope, it is possible to observe the two separate stars, making the binary one of the most beautiful binary stars ever found. Proxima Centauri is too faint to see unaided, and through a telescope it appears about 4 diameters of the full moon away from the other two. NASA says Alpha Centauri A, also known as Rigil Kentaurus, is a yellow star of the same type G2 as the Sun. It is 3 times closer to Earth than the next nearest star like our Sun. Whereas Alpha Centauri B is an orange K1 type star slightly smaller than the Sun. Proxima Centauri is a red dwarf about 1/8 the size of the Sun. EarthSky.org reports that the system is in the southern sky and is not visible above 29 degrees north latitude, a line that passes between Houston and Orlando, Florida. When you're in the southern hemisphere, you can easily find the Alpha Centauri system because the Southern Cross points the way, delta to Beta Crucis. Its right ascension is 14 hours 39 minutes 41 seconds, and its declination is -60 degrees 50 minutes 7 seconds. Astronomers discovered an Earth-sized planet orbiting Proxima Centauri in August 2016. Researchers found that Proxima B has about 1.3 times the mass of Earth, which indicates that it is a rocky exoplanet. In addition, Proxima B's relatively short distance from Earth makes it a very attractive target for scientists. The planet is also in the star's habitable zone, that distance from a star where liquid water can exist on a planet's surface. Proxima B is located just 4.7 million miles, 7.5 million kilometers, away from its host star, and it completes one orbit every 11.2 Earth days. Although Proxima B is huge and located close to the Sun, it remains unclear how habitable it might be from the telescopes we have today. To better understand how habitable the planet might be, astronomers need to run more models and do more comparative studies. As a first step, scientists need to be able to detect signs of an atmosphere. Using this information, investigators can extrapolate whether liquid water can flow over the surface of that atmosphere. Even the surface temperature of the planet, which could affect habitability characteristics, depends on the atmosphere. Another possibility is that the planet is so close to its star that it is tightly locked, meaning it always shows the same face to its star, similar to how the moon shows only one side to Earth, the near side. This arrangement would make one side of the planet very warm, and the other very cold, and less winds could distribute the heat around the planet. Even if that drastic temperature difference exists, it would be a severe challenge to any life. According to a recent study, planets orbiting the Sun-like Alpha Centauri stars could be carbon-rich worlds dotted with diamonds and graphite, which they view as signs of their carbon-rich composition, astronomers said. Although the existence of these planets has not been confirmed, the team of researchers argue that modeling their hypothetical mineralogy, interior structure, and atmosphere can inform future observations, because it can shape our understanding of what is possible. In addition, Proxima Centauri's status as a red dwarf probably reduces its habitability. Red dwarfs are unstable, especially when they're young. Red dwarfs produce a lot of stellar activity and emit charged particles that can cause radiation on Earth. Studies led by NASA Goddard Space Flight Center in Greenbelt, Maryland, show that some of this radiation can strip molecules off the tops of planets' atmospheres and thin it over time. Researchers continue to study red dwarf stars to better understand whether worlds like Proxima b are habitable. TESS, NASA's Transiting Exoplanet Survey satellite, is good at spotting planets around this class of star. Back in November 2017, scientists discovered Ross 128b, another planet in the habitable zone of a red dwarf that's close to Earth but a lot quieter than Proxima Centauri. In order to find out more about its atmosphere, we'll need a ground-based telescope. Researchers say the potential evidence of extraterrestrial radio signals coming from Proxima Centauri, the nearest star to Earth, is probably the result of human technology causing interference. Those mysterious signals were first detected in 2020 by the Breakthrough Listen project, which is searching for evidence of alien technosignatures, radio waves, and other evidence of extraterrestrial technology. This initiative uses some of the largest radio telescopes in the world to measure swaths of the radio spectrum in the direction of celestial objects. Scientists say BLC-1 is an extreme example of local interference, in the sense that its properties are very different from other interference, so it could be used to mimic a real technological signature. The fact that it took us so long to analyze everything so we could draw a conclusion shows just what a challenge this signal was. In particular, when it comes to BLC-1 and its 60 fellows, the signals appear to be spaced at regular frequency intervals in the data, and these intervals seem to correspond to the frequency of oscillators that are commonly found in electronic devices, Sheikh said. This suggests that these signals are coming from human technology, but the scientists can't pinpoint their origin. Even though this signal was generated by human radio frequency interference, it was unique in that it resembled the kind of signal we would expect from space, Sheikh said. The signal fooled our algorithms to filter out radio frequency interference, and it took months for us to analyze and gather the data to realize it was caused by humans. A signal of interest has never been studied this carefully before in the history of SETI. Search for extraterrestrial intelligence, so it's a groundbreaking discovery. This data is being made available to the public by Breakthrough Listen. Simeon says he'd like to finally figure out where BLC's 1 comes from. As we dig into Park's data, I think we'll have a good shot at it. So, yeah, there is much more than we could possibly expect. Anyway, what do you guys think about this Alpha Centauri? Tell us in the comments. And that's it for the day, guys. We'll see you in the next one. Until then, peace.